Good afternoon, everyone. We are Group 51, and today we will be presenting the conference paper titled Automated Exam Script Checking Using Zero-Shot LLM and Adaptive Generative AI. These are our group members. This presentation. Let's begin by looking at some background details about the paper. This paper was presented at the 2024 IEEE International Conference on Computing, Application and Systems, also known as COMPASS, which took place on September 2025 and 2024 in Bangladesh. As of now, the paper has been cited twice, indicating that it has already gained some recognitions in the research committee. Now, let's take a quick look at the authors of the paper. This paper was authored by a team of 5 researchers. They are affiliated with 3 prominent institutions in Bangladesh, as shown on the slide. Now, we have covered the background and authorship. Let's move on the main problem addressed by the paper and the motivation behind this research. Let's take a closer look at the problem this research aimed to solve. As we can see, manual exam grading is a significant challenge in education today. It's a time-consuming process. Educators spend nearly 20% of their time on grading, which limits their ability to focus on more impactful areas like student guidance and research. There is also a major concern about subjectivity and inconsistency. Different graders might interrupt answers in different ways, which can lead to unfair scoring and negative affect students' mental well-being. Also, let's not forget the issue of human error and bias. Even with the best intentions, mistakes and personal judgment can influence grades, affecting accuracy and fairness. Scalability is another key issue. With growing class sizes and more complex assessments, maintaining a fair and timely grading process becomes extremely difficult. So, what's the solution? The authors propose an automated exam checking system that leverages zero-shot LLMs and adaptive generative AI. The goal is to make grading more efficient, consistent, and fair while significantly reducing the workload on educators. Okay, now that we understand the problems and motivation, let's move ahead and explore the research methodology they use to design this system. Over to you, Shashini.
Thank you, Yashoda. Then we will go through the research methodology from this research paper's address. In here, you can see that in this slide, next slide, there are several types of technologies we were used in earlier research papers. So, automated answer evaluation has been rapid in advancement in recent years. So, several methods have emerged designed to handle different aspects of grading. So let me briefly take you through the key ones. So we begin with the first one is the keyword and the bank of the words approach, which match words between student and model answers. While easy to implement, they often fail when students use synonym and paraphrasing. And this other one is the rule-based parsing system that goes a step further by analyzing grammar and sentence structure. To like the Stanford parser help to extract a subject-verb-object relationship, but these methods often require manual configurations and struggle with unstructured answers. So another one is spell checking and preprocessing pipeline that enhance the input quality by fixing grammar and spelling issues through they don't grade directly. The other one is the visual diagram-based question scoring. For subject-evolving diagrams or visuals, image-based evaluations uses OCR and component matching, but this is only applicable to structured formats. So other one is more advanced system use deep learning model like LSTM CNN, which can capture the context of long answers. However, they require large data set and lack of explainability. After that, they move for the OCR plus NLP method for evaluating handwritten scripts, converting physical exam into the digital form before applying semantic analysis. Another way is a semi-automated system that educators provide key answer points and the system check for their results. This offers a balance but still relies on manual setup. Another one is a generative AI and answer validation. In this, most promising are generative AI model like GPT-4, which grade based on semantic similarity and can handle unseen questions using zero-shot learning. However, validation is important to prevent hallucinations. And finally, some systems use summarization where student answers are condensed and compared to the model summarizes, effective for essays to the less precise for technical content. These are the methodologies these research papers addressed from the previous research papers. Then we will move further how these research papers address their methodology. In that, first I would like to move for the data preprocessing steps they address in their methodology. In that, this image indicates that how this methodology were used in their implementation. In that, it's begin with the stop word removal, eliminating common words like the and that at title value focus instead on important terms like system analysis. Next, in tokenization, is split into individual words and convert them into numerical vectors that that model can process. This is followed by data cleaning, remove irrelevant content, eliminating duplicate and instantaneous formats to ensure consistency. Finally, it used TF-IDF for feature extraction. This highlights words that are more frequent in a student answer and rare across others, helping to focus on what really matters. Together, these pre-processing steps ensure the input is clean, structured, and ready for AI-powered grading. So that's the pre-processing steps this methodology addressed. Next, we will go through the full implementation methodology of this project addressed. For that, I will like to hand over this to Netmi. Netmi, over to you. Thank you.
Thank you, Shashini. So let's move into the next slide. So let's have a look at the scoring methodology used in this system. First of all, students upload their answer scripts to the system, and at the same time, teachers also upload their model answers to the system. So scoring happens basically semantic analysis with the model answers. So as Shashini introduced, before these data saved in the database, text is pre-processed like methods used by tokenization, stop word removal, and lemmatization, and then the feature extraction happens by TF-IDF, and finally students' answers are scored based on their similarity score with the methods used by cosine similarity, checkword similarity, bigram, and trigram similarity. So let's move into the next slide. So, however, these answers are scored a value between 0 and 1. So finally, these values are converted into a percentage. However, these marks can be differ based on the longer answers with relevant content score higher, and grammatically spelling errors may slightly penalize results, and missing key terms reduces the score. And the system displays similarity percentage, and however, teachers can adjust these thresholds also. Let's move into the next slide. So finally, through this methodology, the system achieves these kind of benefits: recognizes non-standard but contextually accurate answers, ensures fair evaluation beyond keyword matching, and captures semantic containing for deeper comparison. So let's have a look at the experimental setup of the system. So in the system, as you can see in this image, there are 3 roles who contributed into the system. Basically, teachers log into the system and they upload their question paper and sample model answer paper to the system. And these 2 documents are pre-processed as previously mentioned and saved in the database. And students may also log into the system and then enter their answers. And these model answers and students' answers are analyzed based on similarity check, and finally results will be displayed. So students will be able to see their own scores, and teachers will be able to see overall marks of these students. However, finally, to check the performance of the whole system, the manual grading is the system's grading is compared with the manual grading in terms of time efficiency, accuracy, and scalability. So let's see how these values, this performance analysis in values. So it's over to you, Amisha.
Thank you, Nithini. Now I will walk you through results and performance analysis and discuss the broader impact of this research. The results demonstrated impressive performance. The system achieved an overall accuracy of 94.32% compared to human grader, and the maximum absolute error recorded was only 0.1, which shows how precisely the system can replicate human scoring. And for annotated questions, the system's average relative error was 1.29%. Even for non-annotated questions, where the system had no prior examples or context, the average relative error was still low at 1.67%. These findings highlight the system's robustness and consistency even in handling new questions it has not seen before. Let's move on to the next slide. Key conclusions and research impact. Under this, first let's talk about the primary research contributions. Summarizing the primary contributions highlighted in the paper, the researchers successfully developed an automated exam checking system based on GPT-4, achieving high accuracy, and they integrated generative AI techniques to refine and improve answers, ensuring fair grading. They implemented semantic and synonym similarity measures to recognize correct answers, and they achieved low relative error rates, demonstrating the system's precision. The paper emphasized the transformative potential of this approach for education. Some key benefits include efficiency by significantly reducing the time and resources needed for grading, and consistency by applying uniform evaluation standards across assessments, and scalability, making it adaptable for various educational settings, and objectivity as it removes the risk of human bias from the grading process. Let's move to the next slide. The benefits extend across all stakeholders. Educators can devote more time to teaching, research, and skill development instead of spending hours on repetitive grading, and students receive fair, objective assessments, fostering academic equity and trust, and institutions can improve the overall quality and standardization of their assessments, leading to more reliable educational outcomes. In terms of future directions, the authors suggest that this technology represents an important steps towards modernizing educational assessments. They propose exploring further improvements in accuracy, expanding the system's capabilities to different subjects, and incorporating feedback generation for more comprehensive educational support. To conclude, the authors emphasize the significance of their work. It addresses key challenges in educational assessment such as subjectivity and workload, and it demonstrates how large language models like GPT-4 can be practically applied in education, and it lays a foundation for developing future automated evaluation systems. Also, it contributes valuable insights to the growing research field of AI in education. So that's the end of our presentation. Thank you all for your attention.